Hello and welcome back to the PreSales Insight series Transforming into as a Service, where we go the complete journey from an offering as a CapEx into an as a service offering. My name is Sascha Oehl. I'm a PreSales leader here in Europe and I lead PreSales organizations and help them to grow in individual fields, starting from technology over the organization into the financials. So what we're doing today, we're looking into the second module of our 3-module journey. In the first module, we've discussed the basics, the wordings that we have to look for in a contract when we go in as a service. In today's sessions, we look into how we get from a solution into a capacity as a service. And then in the next session, we add some other as a service stuff, put some flexibility on top, and to make it a full scalable as a service offering. This is done partially in PowerPoint and partially in Excel sheets. So let's start today with the part 2 of the journey from the solution to the capacity as a service. Our agenda today. Firstly, we will look into a CapEx view of the solution. When we have done this, when we've built a CapEx solution, we're porting it into utility pricing with very few factors and a very basic thing. Then in the next module, the module 3, we're adding some management, hosting and some flexibility to make it more complex and to make it more customer oriented. I suggest we start and let's work it step by step. And as always in life, it's good to begin small and then to add the additional steps on top. So for our first step, for the level 1 solution, the CapEx solution, we will map out the capacity per period, like quarter in our case. We will add some buffers. We will map out the building blocks that we need to fulfill the requirement. And we map the CapEx cost to have an overview of the solution over the time. To do so, we need some stuff. We need design parameters like the initial capacity of the customer, the growth rate, space for unplanned growth and for planned growth that in fact or implies a higher number of units that we have to provide. On the other side, we need our building blocks. The base building block, like you can say the initial part of a machine, plus the upgrades we are adding on top. We need the price and the price erosion per building block, the environmentals, like the space that they consume and the power, the capacity that they are delivering, and the number of upgrades we can do on one base. Doing this, here are our assumption for our module. Firstly, we're looking into a quarterly view. We look at a quarter view for 5 years, so in sum 20 quarters. Our customer has an initial used capacity of 17,000 terabytes and is growing by 20% year over year. We want to have some 5% buffer for growth during the period and another 10% for short-term requirements. The 5% is for the growth that's happening during the quarter, the other 10% for peaks and usages that are very unplanned. We make it simple. So the solution is not like a configured solution, it's a theoretical solution to make it work here a bit easier. So we've got a base unit, it delivers 1000 terabyte capacity with 800 kilowatt hours, 4 space units, and it costs us like 100k with an 8% price erosion year over year. The upgrade unit gives us 750 terabyte. It just consumes 400 kilowatt hours, 2 height units, 50,000 euros and a 5% price erosion. And we can put a maximum of 8 upgrade blocks on one base. These parameters are used to make the calculation a bit easier. In reality, there would be probably other numbers and they would not be so easy like 50,000, 400, 750. You would work with a lot of different numbers here. But for the calculation that we use, this is pretty much doing the job. So what else do we need? Now we're getting back to math. We need some formulas. So the one thing that you always need to do is converting percentage rates. In our example, we're looking into a quarterly view. But we have got yearly percentages, like for price erosion and growth and so on. So we need to convert the yearly percentage in a quarterly percentage, or sometimes in a monthly or whatever percentage. And you see here exactly the formula that we use for it. To put it onto a quarterly, we take the fourth root of 1 plus the yearly growth and subtract 1 from it. So let's say we have a yearly growth of 10%. 10% equals, in decimal numbers, 0.1. We had the formula as you see it here, which would deliver us into 2.411% per quarter. Same works out with a decline. A decline is a minus 5% in this example, and in this case you would convert the minus 5% growth into a minus 1.274% per quarter. You see the Excel spreadsheet formula also there. It's a formula that we need a lot during the next minutes. The other formula that you need is applying a percentage for growth over multiple quarters. Let's say you know your percentage of growth for a quarter, like 10%, and you have 3 quarters of growth. So what would be the summary? What would be the result of the equation? And you see here, we also work it out in some formulas. And you can see 10,000 capacity with a quarterly growth of 10% for 3 quarters is basically giving us 13,310 units at the end of 3 quarters. You don't have to know all these formulas from your mind, but it's good if you have them and see how the things are working together and what the meaning of the formula is. Unless you know it and you've seen it before, a spreadsheet could look very, very difficult when you look in all the different cells and find formulas of this length maybe. But if you know these formulas, you can quickly interpret. Now, let's go into the spreadsheet and make some calculations. Okay, now here we are. We've opened our favorite spreadsheet tool. It could be Excel as in this case, but it could also be LibreOffice, or it could be Numbers, or whatever you like. Basically, what we're doing now is an easy job for every spreadsheet program that you have on your computer. So I've prepared some steps here, and we go with them step by step. So as promised, the first thing that we would do is we go for the level 1, the CapEx view. The first thing that we do here is we put in the upper part every parameter that we already know. So for example, we know the initial used capacity, which is 17,000. We know the year-over-year growth, 20%, and we use our formula to turn this 20% year-over-year growth into a quarterly growth factor, which is in fact 4.66. We know the space that we need for growth, for short-term requirements, and we add it up, which brings us into 15%. On the other side, we've got the building blocks, as we've described before. Our base building block comes with a cost of 100,000 euros, brings us a capacity of 1,000, has a price erosion of minus 8%, which we turn out into a quarterly erosion of 2.06. 4 height units and a power consumption of 800 kilowatts. Same thing for the upgrade. Cost is like 50,000, capacity 750, a maximum of 8 upgrade blocks per base, a price erosion of minus 5%, which turns out in minus 1.27, and it comes in 2 height units together with a power consumption of 400 kilowatts. Together this gives us a maximum capacity for a base plus the 8 upgrade blocks of 7,000 terabyte. This is now the baseline of our calculation. In the next step, you see I prepared here a small chart which gives us an indication on how the capacity that the customer is using will turn and grow within the quarters. What we did here we mapped the quarters to the top with a year and a quarter number and the absolute quarter, which we need for some calculations. Then we started with the 17,000, and you see here, let me mark it. Basically, we take the D2 cell, the capacity that we've got initial, and multiply it with the increase, the growth that we have quarter by quarter, and use then the quarter to have the factor of it. So powered by the quarter. You see here we subtract 1 because obviously in the first quarter we don't have a growth factor, and so we are always 1 quarter back when it comes to the power factor that we apply here. This brings us in this case to the 17,000. When we look now through the quarters, we see exactly the same formula, quarter by quarter. And we see how the growth turns out into like 40,000 in 20 quarters. Now we look at it just for an information purpose, and we calculate the petabyte instead of the terabyte by dividing it into 1024, and we're adding the capacity and the buffer. In that case, we take the capacity we've calculated here in the blue cell, and we apply the buffer, which is in the red cell, part of our input data. This now gives us an overview of the space and the growth over the quarters. So this is the demand of our customer. The next step that we do is we look at it and say what we need to deploy to fulfill the demand. You see here, we are basically working with the customer demand that we've calculated in 9 to 14. And we calculate here how many base units do we need. So we divide it by the capacity that we need by the max capacity and round it up. This gives us the number of base units that we need to fulfill the space requirement. In the next step, we calculate the upgrade blocks that we need. You can see here, basically, we are calculating the difference of what is already deployed by the base blocks, and then we divide it by the capacity of the upgrade block, and then it turns out into a number which grows quarter by quarter. You see here in the beginning we would start with 3 machines with 23 upgrade blocks, but right in the third quarter we would upgrade to 4 machines until the 9th quarter where we need 5 machines, and so on until the end where we need 7 machines and 53 upgrade blocks. Having these numbers, we can easily calculate what is the capacity that we have deployed, what is the capacity that is on site of the customer. This capacity is slightly higher than the capacity that we need because it's driven by the upgrade blocks. For our financial calculation, it is important to understand how many base and upgrade blocks we are deploying in each quarter. You can see here basically the numbers where we figure out what is the number of blocks that we need to make the growth. We look into our quarter, we look into last quarter, and basically we're just building the delta and put it in here. So for example, in this case, in the 5th quarter, we would simply have to deploy 1 upgrade block. This now gives us the baseline of the components that we need to deploy. The next step, which is logically on top, is calculating out the cost of each quarter. What we do for it is basically we take, again, similar approach as we did with the capacity used. Yeah? We take the cost that we have in the beginning, the 100,000, multiply it with the growth, 1 plus minus 2.06, it's a negative growth, and power it up with a quarter minus 1. This gives us a price of 100,000 in the first quarter, exactly as we have defined on top, and then the price goes down by 206% quarter by quarter. So in the 20th quarter, we would pay for the same base block like 67,000. Exactly the same we do for the upgrade block. Both together gives us a cost per each block per quarter. You could also put it into one equation. By doing it that way, it's easier, and you could see and you could easily explain to someone else how you could calculate the cost. In the next step, we are calculating the total cost. To do so, we multiply the number of base blocks with the price of a base block in that quarter and add to it the number of upgrade blocks multiplied by the cost for the upgrade block for this quarter. And this gives us then a cost that we have to carry each quarter to cope the customer demand. Summing it up, no financial impact here of interest rates or so, it sums up to somewhere above 3 million. This is a first step that we do. With this understanding, we know what hardware we need to fulfill the customer demand and what costs would be associated with it. Now that we've got our CapEx view, we have to do the next step. We will add the aaS service module. To do so, we have to calculate the cost for the solution. We add financing, we add our hurdle rate, and we calculate this amount over the units that the customers will be settled. Firstly, we calculate a flat pricing, which means a unit has the same cost in quarter 1 and in quarter 20. Then we factor in the financial benefits. Like if you give me money in the first quarter, I can put it on a bank, or I can use less interest rates that I have to pay for a bank. And then we bring in the price erosion. So having a quarterly decline of the prices. In reality, quite often this is more done on a yearly base, but for this example, we're doing it on a quarterly base too. So what do we need to do these steps? Firstly, we need to know our interest rate. So what is the price that we are paying for getting money? Second, we have to know our interest rate for saving. So what is the benefit that we get if we put money on a bank? And we need our internal hurdle rate. Then we need some payment parameters. Like, is the customer paying in advance or after a quarter? You see, it's 3 months different between getting the money. This makes a difference because you have to pay interest rate for this time. Is a provider paying in advance or after the quarter? And what unit price erosion do we expect? For our example here, we go with these parameters. The interest rate for saving money is 1%. The interest rate for lending money is 2%. Our hurdle rate is 5%. The vendor have to pay in the period, so we pay for our kit in the period, while the customer pays after the quarter. And the customer demands a price erosion of 5% over the year. Now, let's put this into a calculation and let's go back into the spreadsheet and make it work. Yes, now that we are back to our calculation, we are now going into a basic as a service calculation. As we did before, we put everything that we know on the top of our sheet. The interest rate for saving, with a quarterly equation to it, the interest rate of lending money, the hurdle rate that we have defined, if the customer is paying in the month or after the month, and if we pay in the month or after the month, and the price erosion of the unit that the customer demands. In that case, a price erosion of -5% for the unit for the year, which turns us in a quarterly of -1.27%. This again is the input parameters that we use for our calculation. The first step that we do now on our journey to have a capacity as a service pricing, I did some preparation here before, we start again with mapping the quarters on the top, the used capacity that the customer is using and we are settling the customer for, and the cost that we've calculated in the last sheet. You see, these are exactly the same numbers as we have seen before. It turns out that over the period of 20 quarters, we are settling like 542,000 units to the customer, which is 3 million of CapEx costs that we have to carry. Now, with this in mind, we understand that we have to finance our CapEx cost to turn it into an as a service. We know that we can lend money for 2%, and this is what we're calculating here. In this calculation, you see, we are checking what's the amount that we need to lend. Then we are putting in the uplift of it, 1 plus 0.5. We're giving it a power, which is basically the number of quarters that we have to lend the money for. And in the end, we are subtracting the cost that we have here to have just the financing cost that we have for the investment of each quarter for the term of the contract. This is what we're doing here, quarter by quarter, in this little Excel sheet, which gives us in the end a financing cost of 220,000 euros over the period. Adding it up, the cost that we are carrying plus a finance cost gives us a cost impact for each quarter. Now we said we don't want to do this project just for fun. So we have a hurdle rate or a minimum margin that we have to generate. In our case, we defined it with 5%. This is what we're adding up here. So we're calculating it basically exactly as the hurdle rate and adding it up. Now we have everything together. We know all the costs. So we have a total cost of 3.2 million, including the hurdle rate and all the other stuff. We have a cost like 3.944 million, which is basically kind of 4 million. This is now giving us the cost that we have to carry over the period. In the next step, we think about a flat pricing. So if we have a flat pricing, so the unit has the same cost in each quarter, so there's no price erosion, we can do it pretty simple. You can see it here. We have basically the total cost including the hurdle rate. We know the total number of units that we can settle, and then we divide the cost of the hurdle rate, including the hurdle rate, by the number of units we settle, and we get a price of 7.27 euro per unit. Multiplying it out, so the number of units multiplied by the unit price gives us an income per each quarter, and it sums up to exactly the 3.944 million as we had in the cost sector. But obviously, we can put the money on the bank. So if our customer gives us money in the first quarter and we have a financing contract anyway for all the quarters, we can put the money, the 120k, on a bank and generate some interest. So this is what we're adding here. So we know exactly what we have on units that we could settle. We know exactly the interest rate for savings. So basically we put a financing factor on top of the unit rate. A unit that we sell in the first quarter has a higher worth because we get interest, we get saving percentages for it, compared to one unit in the last quarter. This gives us like a unit number including our saving rate. Now this turns out into being 553,507 units. What we do now, again the flat pricing, as you may expect now, we divide the total cost including the hurdle rate by the number of units including the saving interest rate, and we get a price of €7.30. This would be the income, and you can multiply it out easily, but be careful, if you multiply it out, you have to multiply it with the number that the customer is really using, so the used capacity. This is what we're doing here. So we're multiplying line 29 with line 12. We're doing it month by month. You can see here. Of course, this is now a lower number because we're using exactly here the same multiplication before, but we can settle like 14 cents less per unit. Now we're adding again the interest and saving rate. You can see here it's the same calculation as we did before with all the other stuff, which gives us basically for the 121,000k that we get in the first quarter, an additional 5 or 6k on savings that we could add on top. And if we add it, this sums up to 127,001 euro 95 cents, and we do it quarter by quarter. We make the sum of it, and we are back with the 3.944,192,41 that we've seen before. This would be now a flat pricing per unit, including the financing cost and the financing benefits that we have. But of course, our challenge was different. The customer asked us to work with a price erosion quarter by quarter. And how we do this? Basically, we follow exactly the same logic. The price erosion gives us a different worth of each unit that we settle in each quarter. So, you see it here, we're adding the erosion. In the first, there's no erosion, but in the second quarter, you see the difference. We are not calculating anymore with 18,608, we're calculating with 18,371 units that we settle. And you see the number of units that we settle is even less than the number of units that the customer is working here for. Why is this? Because the units that we're using here are calculatory units, and it includes the price erosion. So one unit in the 20th quarter is less of a worth compared to one unit in the first quarter because of the price erosion. When we do this, we can make the calculation again. We know we will settle 488 units over the time when we bring in the price erosion. Now, for the first quarter, the price is pretty simple, calculated like before. We calculate the number that we have as a total cost divided by the number of units we put in totally, and we get a price of €8.30. $0.17. Going for the second quarter, we see that the price erosion kicks in. We have it here. It's working with the power of 1, 2 minus 1, and it brings us down to a price of 807. And this is what we're doing quarter by quarter until the 20th quarter. I'll be doing it with a power of 19 to reflect the price erosion of all these 19 quarters. This drives down our unit price to €6.41 in the 20th quarter, but it was €8.17 in the first quarter. For us, this is simply moving around money, as we have still to carry the same cost as before. Now let's see. We look at the income again and we multiply the unit price that we have calculated for each quarter, including the erosion, with the used capacity that we have got from the customer. This gives us an income. We add up the interest rate again, same procedure as before, and we get a total income. And you see, in the first quarter it's even higher than it's in the other calculations. And why is this? Yes, you can guess it, because the unit price is higher, because the price erosion is just shifting around the money that the customer has to pay. When we sum it up, magically we end up exactly at the 3,944,192.41 euros as in before. This has now moved our prices that we had for the capacity in a CapEx model into a flat pricing with interest rate, and with added price erosion over the quarters. With these simple steps and a bit of magic in the spreadsheet, we have been able to turn a CapEx price into as a service price for a capacity. This is the beginning of our journey, and in the next sessions we will move up with the rest. Now that we've figured out our first as a service pricing, a flat pricing, a price including financial benefits, and a price with price erosion, we have done our very first step. We've managed to get from a solution into a CapEx view, into a capacity as a service. This is the stuff that you could charge your customer for on a quarterly base to have the CapEx view fulfilled. Now, this is just the beginning of our journey. In the next session, in Module 3, we're looking at adding management, hosting, and flexibility for scale up and scale down. So, good job for today, and I'm looking forward to see you again in Module 3.